Hey there! So we finished yet another part of the course, namely streaming and governance. And I know it wasn't a big part, but it deserves a summary, so let's get started. Alright, so governance and streaming. Let's try to summarize this area and let's give you a challenge so you could practice all of the stuff that I've been talking about. So streaming. So first of all, unlike batch processing, it's a completely different world, different requirements, different type of processing. Because in streaming, we usually have some data producers, those event producers, that are constantly producing some data that our solution has to process in real time, basically without any delay. And it differs a lot from batch processing, where, alright, we had some data producers, but they were just producing the data, but we were processing them once, maybe twice a day, usually during the night. In streaming, it is different. We have to process data as it is produced. Which means that our architecture and used services will be different compared to batch processing. So actually, let's draw our maybe not typical architecture for streaming, but the architecture you have to be familiar with for the exam point of view. So as always, we have some data sources, and let's say we've got some IoT devices, some smart sensors located maybe in your home, in a factory, or anywhere else. We might have various logs that you would like to analyze. Logs that are generated in real time, and you would like to process those logs as they appear. You might have some streaming data sources, streams. So basically all of this stuff are our data sources or our data event producers. So basically, regardless of the type of processing, batch or streaming, we always have some data sources because we always need to have a place from which we take data for processing. But later phases, they differ. Well, conceptually, in both cases, batch and streaming, we have to somehow ingest the data to Azure. We have to make it available for further processing. But for streaming solutions, we've got two services that are dedicated for this type of scenarios. Namely, we've got either, wrong icon, something like this. We've got IoT Hub that should be used basically in case of processing data from IoT devices. Because the nice thing about IoT Hubs is this bi-directional communication. So from your source and to your source, if that's required. But usually for big data scenarios, you would use a different service for ingestion, which is called Event Hubs. So these two we could use simply to ingest data to Azure. We will not be processing it yet in any way. It is just available for further steps. So basically all those data sources, those data producers, they need to have a place to which they could send the data. And we could use either IoT Hubs or Event Hubs. So it would be something like this. Alright, so once the data lands inside Azure, we can start processing it. And now, from exam point of view, you have to be aware of a single service that does the job, namely Azure Stream Analytics. But please be aware that it is not the only solution, not the only service that could be used here. In real life, in many cases, Databricks is used. But for the exam, you have to know about Azure Stream Analytics. So let's add it to our diagram. So it's something like this. Azure Stream Analytics. And basically, Azure Stream Analytics is a service that is able to connect to IoT hubs, event hubs, and some other data sources like data lake or storage account, just to process the data that was ingested. And then it can apply some logic based on which we would like to analyze our data. For example, we usually don't want to aggregate our whole stream because it's not possible. What we do is to split it into those parts, those windows, and then calculate our aggregations, our logic on those smaller windows. So basically, in our architecture, Stream Analytics is used to basically analyze the data. And once the data is analyzed, well, it can be sent to end consumers, whatever it is. For example, it might be Power BI. So Power BI, it might be some data lake. So ADLS. It might be a regular database. And so on. There are more types of outputs that could be used from Stream Analytics, but these I would say are the most common ones. So basically, that's the flow of our data. First, we ingest it to Azure using IoT hubs or event hubs. Then we process it using Stream Analytics, and then we send it to some end location using one of those output types that are supported by Stream Analytics. Now, the nice thing about Stream Analytics is that, well, it can use not only the data that is coming from our streaming sources, but it also can use reference data. That is static data. Reference data that lives in Azure SQL database or data lake or blob storage. For example, it might be some kind of a dictionary that doesn't change that often, that you would like to use to join with the data coming from the streaming sources, and then produce this nice user-friendly output to your destination. So that's one thing. Secondly, Azure Stream Analytics has various window functions that we could use to write our logic. And basically, when we are writing our queries in Stream Analytics, we use this SQL-like syntax. I think it is called SQL Analytics or something like this. So it is not pure Transact SQL, no, but if you know databases, it should be very easy for you to start using this dialect used by Stream Analytics. And basically, inside Stream Analytics, we've got 5 window functions that we could use. And just to remind you, there were as follows. So we got tumbling window, the easiest type of window functions that simply splits our data into those equal windows without any overlap and without any gaps. And then we write our computations, our analysis on data from every window. As simple as that. Then we've got hopping window, similar type of window function to the tumbling one, but in this case we can define this overlap between 2 consecutive windows. So basically you can define how big the overlap between two windows should be. So in this case, the same event might belong to multiple windows, which is not possible in case of tumbling windows. Then we have sliding window. And sliding window is interesting one because in this case we've got this window that is constantly moving for time. And whenever the content of the window changes, it outputs, well, the window. So it produces the data that is later used as a source for our queries. Then we've got session window function that is used basically to group those events that were produced close to each other from time perspective. For example, we have a user that started to click on your website and you would like to track his movements, his actions. And finally, the last one, snapshot. This one is used simply to find those events that were produced at the same time. So those 5 window functions, so actually let me write it. So we've got window functions. These are extensions to regular SQL dialect that you might know that is available only within Azure Stream Analytics. And basically, you will have to use any of them. Which one? It depends on your requirements, it depends on your logic, but sooner or later you will have to use them. So please make sure to understand what they do and how to use them. So that's it. And then when we think about streaming solutions, we have to be aware of various issues that didn't exist in case of batch processing, namely time. Time is super important, especially if we want to process our events in the order in which those events were produced. And why this is important? It's like this. In the case of streaming solutions, we've got these 2 types of time, the most important ones. So we've got event time. Actually, let me draw it under our diagram, just to help you memorize where this time is produced. So event time is here at the event source, or it is called sometimes application time. So that's the time when this event was actually produced, when something happened. And the thing is that neither IoT hubs nor event hubs is aware of this thing because it happened outside of Azure. So if you need to process your data using this event time, the real time, then you have to make sure to include this event time into your events that are sent to Azure, because otherwise there is no way of knowing this value. Then we've got arrival time. So that's the time when specific event arrived to Azure, to any of those ingestion services like IoT hubs or event hubs. And now we know that here, between those 2 phases, something bad might happen due to the nature of the network, of the internet. So first of all, what might happen is that, well, there might be some delay, some latency, bigger or smaller, between the time the event was produced and the time it was sent successfully to Azure. So depending on your requirements, you might not accept events that arrived too late because, well, you no longer need them. So you have to do something. You have to decide what to do. Do you want to remove those events or somehow adjust them? So that's one of the issues. Secondly, your events, well, they might arrive in different order compared to the order in which they were originally produced. Because again, you have no impact on this. You have no impact on the way those events traverse over the internet. And again, you should ask yourselves if it matters in your case. If you are fine to process data based on the order in which they arrived, if yes, you are a lucky guy, because a lot of issues just disappear in this case. Or you have to process them based on the time how those events were produced. In this case, you have to think and you have to do something to make sure that your processing is working fine. Fortunately, Azure Stream Analytics has those policies that we could use to somehow handle those late arriving events or those which arrived out of order. So yeah, we've got those two policies. Basically, in both of them, you can specify this time that should be taken into consideration for both policies. And then you can decide what to do with those events that arrived outside of this window that you've defined. So that's a way to fix your data a bit. So that's it. And then one more thing is that in many cases, when you are dealing with streaming solutions, they were chosen because, well, the results here have to be processed, have to be made available very fast. And depending on your architecture, on the component that you are using, on their compute power, sometimes your solution might not be powerful enough to process the data in a timely manner. And the way to detect this is to, for example, look at various metrics inside Stream Analytics, like this watermark delay, which simply tells you how much time passes between the event is produced and the time it is processed. If this value is getting bigger and bigger, it probably means that, well, your solution is not able to process those events. So they are starting to queue. So that's one of the things you could look at to verify performance of your solutions. And now, if you notice that it is slow, it's not powerful enough, well, you can, as always, throw more money into the solution, buy more powerful solutions, either here, here, and here. That should work. Or you could try to implement this embarrassingly parallel job scenario, in case of which your whole processing will be parallelized in multiple elements, in multiple places. So for example, in the case of event hubs, you would have those multiple partitions to which data would be sent from the source. Then inside Stream Analytics, you would have multiple copies of your query, each of which would be connected to a specific partition from your source, and then you would have to also have partitioned output, just to have this throughput of your solution as big as possible. So that's what you want to have if you see that you've got some performance issues. So that was about streaming. Now moving on to governance. And I know I covered those two things in the same section, streaming and governance. Please be aware that governance does not apply only to streaming. No, it's a common thing that you should think regardless of the type of the solution that you're implementing, whether it's batch processing or streaming or mixed one. And now, in case of governance, depending on whom you ask, you might get a different definition of what governance is. And in one of the episodes, what I did was to give you a definition provided by Databricks. And they simply split, or they defined multiple key elements that together build data governance. And what they mentioned was data cataloging, data quality, data classification, data security, auditing, data lineage, data discovery, and data sharing. So multiple parts that together will help you to govern your data. So important thing, guys, is that data governance is not only about granting access to your data. It's not only about security. Yes, security, it is an important part of data governance, but there are others as well. And now, when it comes to Azure, the solution that will help you to govern your data is called Microsoft Purview. It has multiple solutions inside, and I know that I covered only two, data catalog and data map, but that's a good starting point for you, just to understand what more or less how you can start with data governance. And basically what we did was to define our business domain, this Lego domain, and then within it I created those various business objects like glossary terms, OKRs, I know, strange name. We've got CDE, critical data element, and the most important part was data product. And data product was a collection of data assets that were scanned from our Azure assets. What we did was to scan a data lake. Purview detected multiple directories inside. And what we did was to indicate that one of those data assets, one of those directories, should be treated as a data product. And here, data product means simply this shareable, or this unit of data that you can share with others that is complete. So it contains all the information that is required for someone to get some value of your data. And sometimes it might be just a single data asset, like it was in our case, but sometimes it might be a collection of multiple assets that together give some value to end users. Alright, so that was a very short recap of streaming and data governance. Now, about your challenge to practice this stuff. So what I would like you to do would be to create a very simple streaming solution that will help you to practice this stuff. So, as a data source, I suggest to use this generator created by Kamil Nowinski. You'll find the link to this tool in the video description. And please use this tool to generate data about Lego. And what I would like to have, actually, let me write a very simple JSON data that I would like to see. So this is our JSON. Actually, let me just indicate it in a simpler manner without this JSON syntax. So what I would like to have: publish time. So it would be a current date. I would like to have Lego. I think it was minifig ID or something like this. Basically, identifier of our minifig. Then I would like to have price. and quantity. Only those. And what those events would be, so this is the event that I would like you to generate. So basically, we will be simulating some sales system that detects that specific minifig, this one, was sold for this price in this quantity on this particular date. And let's just use the generator to create multiple events with this data. And now, I would like you to process this data to send it to event hubs. So obviously you would have to create an event hub and configure your data producer to be able to send the data to it. But we did this during the videos, so it should be fine. Then I would like you to deploy Azure Stream Analytics and write a query that would analyze this sale data. And now, depending on complexity that you would like to have in your solution, or how ambitious you are, how much time you have to practice this stuff, let's say that the first version of the solution, absolute minimum, would be like this. I would like to see sum of our sales by price, by the means of price, aggregated by hours. And then I would like to have this data sent to a data lake. So basically what I would like to have is data for every hour that summarizes total sales. So this hour we got 100 euros, for example. The next hour we got 27, and so on and so on. So you would have to choose a proper window function to be able to aggregate this data by hours. So that's a bare minimum. Then, if you feel more ambitious, and I hope you do, then I would like you to use reference data. Why? Well, inside our events, we've got this Lego minifig identifier that points, at least in theory, it should connect, it should match with our Lego minifigs data that we already have inside our data lake, because we've been working on this data so far, and we've got this nice dictionary of minifigs. And now, to make this work, you would have to take a look at our minifigs data and understand how those identifiers are created. And then, in the tool, try to generate those values that could be matched with those IDs. Then, inside Stream Analytics, I would like you to, well, create this reference data that would point to a data lake. So this is a data lake that contains our minifigs data. And inside Stream Analytics, I would like you to write a query that would join our events with our reference data. So we would have this nice human-friendly name of a minifig instead of just ID. And the output of our processing would be similar. Again, I would like to have sales by hours, but also by minifig, but not by this ID, but by name, user-friendly name. So that's the second thing. If that's not enough for you, then I would like you to try to put as much pressure on the solution as possible. So play around with the settings of the event generator to see how much events you are able to send to event hubs. And why? Because I want you to look at metrics available inside Azure Stream Analytics, mainly on this watermark delay. What I would like you to try to do would be to send as many events to your solution, so you would observe the watermark delay getting bigger and bigger, just to see that well, your solution is not able to keep up with the workload. And then, if you see that it really goes up, see what you can do to make it low again. And it's up to you to test various things. What would work in your case? So that's the challenge. And basically that's it for this episode. Thanks for watching and see you next time. Take care.